Hi, physical science. Hope everybody's enjoying this. I'm going to try to teach you a little bit about position versus time graphs. To do that, I'm going to go to PhET. Oh, the first thing is position can sometimes be a little bit confusing, but it shouldn't be at all. Okay, a position versus time graph really just means position versus time, which is on the bottom. So that's your y, and this is your x. Okay, so for example, on a position versus time graph, my little guy here, uh, like Rico Suave right here, look at him. Okay, if he just stands there, if he just stands there, oh, what happened? Okay. If he just stands there, I you notice his position just stays at 0 because he hasn't changed where he is. So again, his displacement is 0. Okay. All right. If for some reason we move him over here to 2 meters approximately, and we stop again, notice his displacement changed, his position changed 2 meters in the positive, and then he stood there. So his position didn't change. Because remember, time continues to move forward. All right. Then if we move him back, it's a little hard to control, but if we move him back, all right, and we're being as careful as we can be here. Okay, if we move him back, notice his position changes again in the negative because we're moving back towards the origin. Okay, and then approximately we get right back where we started. So his displacement or his position again is 0, and that's what we talked about in distance versus displacement. So the whole point is, how do we read these position versus time graphs? Well, if you have a positive, anybody remember what this word is? Starts with an S, a positive slope. Very good. A positive slope. Okay. That means you're moving away from the origin or where you started from. If you have a negative slope, okay, then you are moving back towards the origin. Okay. Now, what's interesting is, and this is what we would do if we were actually in school and doing this, is what if we walked out to this house that's 8 meters away and I can do it in all one motion so it looks good and I stop? Well, we get pretty much a bigger chart than what we had. Well, think about it. If I go all the way back to where I started, how's that graph going to look? Well, here we go. There's a little, and you should have something. Again, in an ideal world, these are nice flat lines, but that's not how the real world is. But here's the interesting part. What if we actually went away, came back, and then traveled through the origin? Well, now we are on the negative side because we are now 4 meters on the negative or in the negative position. Okay, interesting. So think about it. Our original, our original set, here we got to go here and reset. Sorry. Okay, we'll just pause that, clear that. Great. Okay, remember we had our nice little up, flat, down when we went in the positive. Well, we can do the same thing in the negative. Watch this. Okay, if we go out here 4, stop for a second, and then travel back to 0, look at that. We get the exact same thing as if we would go to the positive 4, wait a few seconds, and then travel back to 0. Okay? So again, these are just opposites of each other, and the only difference is because we went in the positive or in the negative. This would be going in the negative displacement, and this would be in the positive displacement. Okay? Now it's a little hard to understand. Maybe it is, maybe it isn't. But we'll give it a try here as we move forward. Hopefully, this made a little bit of sense. Um, if you have questions, guys, I cannot stress to you enough. Please, please use the link in Schoology to email me. Many of you are missing one or two things or could retake things. Do it, do it, do it. Guys, I'm going to give you full points. Just get it done. Please communicate with me. All right. Have a wonderful day, and we'll see you on the other side.